Good evening, ma'am.
Good evening, Apurva.
Yes, ma'am.
Good evening to all. Good evening to all. Yes.
Ma'am, Sushmita ma'am will join, so can we wait for 1 minute? Another participant will join, I think, according to their slots.
Okay. So please start within the time.
Yes, ma'am. Gayatri, please start the session.
Okay, Bhaiya. Okay, is Sushmita ma'am here?
Yes, I'm here.
Okay, good evening, ma'am. So, Bhaiya, am I visible and audible?
Yes, yes.
Okay. So, hey, hi, hello, everyone. Good evening. This is Gayatri, and I wish you a very happy new year. And I welcome you all to the Tripura's Mathematical Association speech competition. Now I would like to welcome the judges of today, Dr. Baby Bhattacharjee ma'am, Assistant Professor and HOD of Department of Mathematics in NIT Agartala. And I would cordially like to invite Dr. Sushmita Roy ma'am, Assistant Professor, Department of Mathematics and NIT Agartala, of today's speech competition judges. Welcome you, ma'am.
Thank you.
Thank you, Gayatri.
Now I would like to invite our first participant, Rashmi Debnath from Tripura University. She is going to give her speech on importance of Vedic mathematics in a student's life.
Thank you. First of all, good evening to one and all present here, and wish you all a very happy and prosperous new year. Now, myself, Rashmi Devnath, a student from Tripura University, and I'm here to deliver my speech on the topic Importance of Vedic Mathematics in a Student's Life. Now, what is Vedic Mathematics? It's an ancient tricks and techniques used by our ancient mathematicians during their time, and we can say this is a shortcut to us to solve mathematical problem in our life. Like as a student, whether it is really important? Yes, according to me, it is a little bit important to us. For example, when a student learns that mathematics is a hard subject, because people used to say that mathematics is a hard subject. To overcome that phobia, one should learn Vedic mathematics because it is a quick, interesting, and a different types of way to solve mathematics in accurate and faster way rather than the conventional method which we are using. We can say this is a shortcut to the old conventional way. So, if a student learns the Vedic mathematics, he or she can excel over others, whether in a competitive exam or whatever exam he is appearing, because today's generation and today is a life of fast growing nation, fast growing competitive world. Even from the social media, besides nowadays social media, video games, etc. are distracting children from creative learning to ready-made learning, we can say. They try to find a solution to a problem in their social media account, and they never uses their own mind. They don't do any creative things. So we can say their memory or mind is getting blunt somewhere. So if he or she could solve the problems in a way within himself faster than the way he will find it in social media and other platforms, he will feel interest in that particular subject. He or she will overcome that fear, that phobia of mathematics and other things, due to which he or she will develop interest in particular subject. So, on developing interest, this will enhances his focus, and he will know that the subject which he or she is studying, is something interesting. Because someone once said, if a student approaches mathematics, he should approach it in a spirit of curiosity and interest. And if a student does not show any interest in particular subject, he or she will not excel in that subject. So whenever a student learns Vedic mathematics, he can enhance himself. He can empower, do creative ideas. He can visualize things in his own way and could solve problem in his own way with recognizing patterns, imagination and imagining things in a different way. Because with this, he could help himself sharpening his mind and memory. As I said earlier, this is a shortcut to our conventional method. There is a saying, hard work often beats talent when talent doesn't work hard. So whatever may be the methods we are approaching, we are trying to learn a subject, we should work hard. With these few lines, I am ending up here. Thank you, everyone.
Well tried, Rashmi. Now I would like to invite Priyanshu Tripathi from NIT Agartala, and the topic he chose for giving a speech is chess and checkers, the use of mathematics in recreational activities.
Am I visible? No.
Priyanshu Tripathi.
Yes, you are visible. Yes. Okay, thank you. Good afternoon, everyone. My name is Priyanshu Tripathi. I am pursuing BSMS Chemistry in NIT Agartala, and I am going to be speaking to you today about chess and checkers, the use of mathematics in recreational activities. To introduce you first about recreational activities. Recreational activities are often done for enjoyment, amusement, or pleasure, and are considered to be fun. Examples of recreational activities are swimming, playing games, puzzles like Rubik's cubes, magic squares, tractors, logic puzzles, and mathematical chess problems. Now let me show you the correlation of mathematics with recreation. Recreational activities have a great role in mathematics learning and developing various skills in solving problems, as well as developing creative and logical thinking. In one way, recreational mathematics is also pure mathematics and is often difficult to distinguish pure mathematics from recreational. Recreational activities go beyond those games and into puzzles and brain teasers that require math to solve, but are not typical learn the formula and apply approach. Instead, using math to solve a problem is a part of game itself. The benefits of recreational activities are many. The first and most obvious is that using math to solve a puzzle makes it more fun for students, with the goal of simply figuring out of the puzzle. Students will find themselves motivated to understand the math principles involved. This can range from playing checkers to solving brain teasers that require basic math skills. Some examples of recreational math include classic games such as chess or any number of card games requiring addition and subtraction. Now let me show you the relationship between the chess and mathematics. It's the most thinking skills of higher order. Analysis of the positions has a lot in common with mathematical problems. Correlation to decide what piece is best to sacrifice at certain points. It introduces a coordinate system with geometric concepts like files, rows, diagonals, and requires constant calculation. Develops visual memory, spatial reasoning skills, and capacity to predict and anticipate consequences. During the Renaissance, the popularity of chess raised exponentially in Europe. When chess rules were created, personalities and scientists formed that began to be interested in the game. This growth motivated mathematicians to solve mathematical problems over the even during the Middle Ages, which involved simple tools to figure out with simple glance and what would be the result counter. As an example, we can talk about the first steel proposed from 18. The problem of 8 test screens on 8 test screens and gosh, but to the scientists interested in this problem. This problem was taken first in chess, so the correct solution was 1972 with the help of computer backtracking. 92 solutions were found in total, where 12 of them are linear independent. That's all from my side. Thanks again for listening. Thanks.
Thank you, Priyanshu.
Welcome.
Thank you, Pranchu. Now I would like to invite Harshajit Chowdhury from Tripura University, and the topic she chooses Euclid's contribution towards the field of mathematics.
The laws of, first of all, good evening everyone, happy new year. The laws of nature are but the mathematical thoughts of God. I am Harshad Chaudhary, a student of third semester IMD, and for the next few minutes I will be talking about Euclid and his contribution in mathematics. So as you all know, Euclid is one of the most prominent mathematicians of the Greco-Egyptian period, and especially known for his works in the geometry and his work in the in his books Element. So Coming to his life, not much is known about him, but as much as we have known from from the works of theorists who collected and wrote about the lives of various mathematicians during his period, especially of Egypt. Now, according to theorists, he was much of a compiler who collected and presented collected and presented his views regarding the as much as known for the progress report. He compiled his work of this earlier man, Hippocrates and the latest compiler before him, Theorius, whose textbooks were used in the academy, probably by Aristotle too, of which there are mentions in the books of Theorius too, and his vital contribution was to gather, compile and organize the network and the mathematical concept of procedures whose cumulating effect was later known as the Euclidean geometry, whose importance are we all aware of. Euclid understood that building a logical and rigorous geometry and mathematics depends on the foundation. A foundation that Euclid began in his book with 23 definitions, like a point is that which has no part, and a line is a length without breadth. Now, he introduced the method of parsing mathematics in form of geometry, resulted by reasoning based upon previously proved results and some self-evident specific assumption called axiomatic geometry. He gave 5 assumptions that he called postulates. Like given 2 points, there always exists a straight line which connects them, and all right triangles are equal. He also gave some specifically 5 unproved assumptions, like the line is only a length and it doesn't have breadth, and the whole is greater than the part. Euclid's writing element was extended into 13 books, much of which is known to that Euclid was much more focused on geometry. But upon reading his book, it is known that book 1 to 6 specifically talks about the 2D geometries. 7 to 11 talks about the elements of number theory, and books 11 to 13 deals with the extreme 3D figures, which later on led to the rise of various five regular platonic solids like pyramid, cube, octahedral, apart from a sphere. The uniqueness of the several books and the platonic level may give the impression that Euclid was an editor of treatises written by other mathematicians, but which to a large extent is true, although it's impossible to separate and assume which was his own and which was adopted. Thank you.
Thank you so much, Harshajit Chowdhury. Now I would like to invite our next participant, Satyam Rijwani from NIT Agartala. And the topic he chose was importance of Vedic mathematics in students' life.
Am I audible?
Yes, you're audible.
Yes.
Problem causing in your life is lacking Vedic math.
Satyam, can you please turn on your camera?
Actually, I connected
Yes.
2 devices.
It is on. It is on. No problem.
Okay,
But
fine.
you should put the light of your camera. Means light is very less
Wait a second.
Hello.
Hello. Yeah,
So
I can't do, actually light is
okay, okay,
proper,
okay.
but
You continue. You
uh,
continue. Like that, you continue. But please don't be late.
okay, okay, okay. Yeah. Problem solving in your life is like an Vedic math, in which the problem can be solved in many methods and getting the same answer. Good evening, everyone. Myself is Juanita, and I'm from BSMS Mathematics and Computing Department from IIT Agartala. And today, I'm going to talk about importance of Vedic math in students' life. So basically, what is Vedic mathematics? Vedic mathematics is a collection of techniques or sutras to solve mathematical arithmetic in easy and faster way. It consists of 16 sutras and 13 sub-sutras, which can be used to solve problems involving arithmetic, algebraic, geometry, calculus, and phonics. Vedic mathematics is a system of mathematics which was discovered by an Indian mathematician Jagatguru Sibharti Ji Maharaj in the period 1911 and 1918, and published his findings in a Vedic mathematics book by Sibharti Ji Maharaj. Using regular mathematical steps, problem solving sometimes complex and time consuming. But using Vedic math, general techniques and specific numerical calculation can be done very fast. Vedic math can definitely solve mathematical numerical calculation in a faster way. Some Vedic math scholars mention that using Vedic math tricks, you can do calculation 10 to 15 times faster than a usual method. I agree to some extent because some methods of Vedic math are really fast, but some of these methods are dependent on specific numbers which are to be calculated. They are called specific methods. Perhaps the most striking feature of Vedic math system is its coherence. Instead of hodgepodge of unrelated techniques, the whole system is beautifully interrelated and unified. The general multiplication method, for example, is easily to reverse to allow one-line division, and simple squaring roots can be reversed to giving one-line square root, and all these are easily understood. Vedic math teaches time-saving methods and build math accuracy. Using these methods, children have scored brilliantly in math. The another advantage of Vedic math that it boosts mental math skills. Mental math is a skill that helps in doing calculation in the head without the use of paper and pencil. So it reduces or eliminates to a large extent of problems which leads to time wastage in calculation. As the child moves up the ladder in the different grades in school, the difficulty of math grows. Hence, to be competitive in math, Vedic math is a blessing. Everyone talks about the advantages of Vedic mathematics. Are there any disadvantages? So, yes, like no general rules. Rules of Vedic mathematics are meant for some particular problems only. There are too many rules. For operations like multiplication, you will find too many rules which is applied for different types of problems. This creates confusion. Not easy to cross-check. Since in Vedic math you will find the algorithms only becomes difficult to cross-check the answers. If we talk about the Vedic math helpful in competitive exams or not, so my answer is yes. It is helpful for some exams like CAT, SAT, GMAT, banking and mathematics Olympiad, but not for every exam like JEE and BITSET. If you know the basic math from the childhood, then it's okay, you can benefit from it. But if you plan to learn in the 11th or 12th grade, believe me, you won't be able to apply it under exam condition as it won't be that fluent to you. Also, tedious calculation is what IT really asks, so it's not really related. The right age to learn Vedic math is 8 years and above. Primarily, the child has to be aware of the basic concepts like addition, subtraction, multiplication. Up to 10, learn Vedic math. Some children start learning Vedic math a little early, 8 years, which is not bad and adds up to their concept and accelerates their confidence level. The children from 3rd to 5th can do junior Vedic math courses, and students from 6th to 10 can do senior Vedic math questions. Not everyone is thinking, why can't we use abacus instead of Vedic math? The simple answer is, abacus is limited and Vedic math is unlimited. With abacus is used as a tool to learn calculation, beat the move up and down for various columns to represent the number. But Vedic math is entirely done in mind. Abacus is more about addition and subtraction, whereas Vedic math brings you everything like addition, subtraction, multiplication, division, square root, cube root, etc. Clearly, Vedic math has an advantages that make students brilliant in math. It has the power that makes human beings genius. This reminds us of Shakuntala Devi, who was called as the human computer in math. She also talks about how Vedic math has helped children in removing fear. Students have been able to score higher ranks in mathematics Olympiads and a lot of shortcuts and techniques, and its application in all the branches of mathematics and not just arithmetic operations. Thank you.
Thank you, Satyam. Thank you for your speech. Now I would like to invite our next participant, Mr. Hemant Shankar from NIT Agartala. And the topic he chose for giving speech is chess and checkers, the use of mathematics in recreational activities.
Hello everyone. I am Hemant Shankar from Mathematics and Computing, and today I am going to talk about chess and checkers. As we all know that we are very much engaged in many recreational activities such as football, cricket, puzzles, chess and checkers. Mathematics plays a very important role in our lives, as recreational activities goes beyond those games and into puzzles and brain teasers that require math to solve but are not a typical approach. Instead, using math to solve problems is a part of the game itself. The benefits of recreational activities are many. The first and most obvious is that using maths to solve a puzzle makes it more fun for students. With the goal of simply figuring out the puzzle, students will find themselves motivated to understand the math principles involved. This can range from playing checkers to solve brain teasers that require basic math skills. Some examples of recreational math could include classic games such as chess or any number of card games requiring addition and subtraction. What does chess require? Concentration, planning, patience, self-control, conduct rules, mistake learning, etc. etc. Therefore, learning chess might affect the ability to concentrate, memory, other types of executive function, as well as increasing intelligence and problem-solving skills. The relationship between chess and mathematics can be seen in a number of ways. Chess promotes thinking skills of higher order. Analysis positions has a lot in common with mathematical problems. Correlation, to decide what piece is best to sacrifice at certain point. Introduces a coordinate system. Introduces geometric concepts. Require constant calculations. Develops visual memory. Spatial learning skills. Capacity to predict and anticipate consequences. Geometry and chess works hand in hand. The final stage of chess game, the end game, is very important. Geometry plays a very important role in it. Even during the Middle Ages, good chess players employed simple geometric rules to figure out with the simple glass at a chessboard what would be the result of an encounter. As an example, we can talk about the famous rule of the square. We can appreciate that the white player has a king and a pawn versus a king. The rule of the square is made to know whether if the black king can stop the passed pawn or if the pawn will promote. This way, chess masters, drawing a simple mental square of the board, know the game result without needing to calculate move by move. Similar to this, we have the rule of bar. Two arrows are drawn diagonally. If they meet, white wins the game. If they do not, the game will end up in draw. During the Renaissance, the popularity of chess raised exponentially in Europe. Different chess schools were created, and personalities and scientists from that era began to take interest in the game. In this growth motivated many mathematicians to solve mathematical problems over the board. The object of the puzzle is to find a sequence of moves that allows the knight to visit every square on the board exactly once. It is a direct mathematical problem related to the Hamilton path problem in graph theory. It appeared for the first time in Arabic manuscript in the 9th century and was very popular among mathematicians from the 18th century. Due to all possible different solutions, Euler presented a very famous solution in the Berlin Academy of Science in 1759 based on the premise divide and conquer. In chess, patterns develop very often. One gets need to use certain types of position or tactical modifiers. This can help finding sequence of numbers and shapes in certain mathematical exercise. This shows the relation between chess and maths in every aspect. This was all from my side, and you have been a great audience. Thank you for listening.
Thank you, Heyman. Thank you so much. Now I would like to invite our next participant, Ankita Das from KV Panisagar, and the topic she chose is importance of Vedic mathematics in student life. Welcome, Ankita.
Pure mathematics, in its way, the portion of logical ideas. Good evening to everyone present over here. Respected judges and honorable members of TMA, I am Juanita Das of Class 10 from Kendriya Vidyalaya, Panisagar. I am going to deliver a speech today. The topic of my speech is Importance of Vedic Mathematics in a Student's Life. Vedic mathematics is the collection of ancient tricks and techniques to do things faster, really, and to execute arithmetic operations quickly and more effectively. Vedic maths comes from the Vedas, especially from the Atharva Veda. It was first received by an Indian mathematician, Jagadguru Sri Bharati Krishna Tirthaji, between 1911 to 1918. He then published a book, which there was their work, and it was named Vedic Mathematics in 1965. It comprises of 16 sutras and 13 sub-sutras. What is the meaning of Vedic mathematics? Firstly, Vedic comes from the word Veda, Sanskrit word Veda, which means knowledge. So Vedic mathematics in a whole means knowledge of mathematics. The 16 sutras and 13 sub-sutras which are there in the Vedic mathematics has a lot of mathematical fields such as algebra, geometry, phonics, calculus, etc. There are a lot of benefits of Vedic mathematics, such as it enables faster calculation, which reduces burden and therefore improves our concentration. Secondly, it improves confidence, which helps in enhanced logical thinking process and saves the time during the examination. There are a lot of advantages as well of Vedic mathematics. Some of them are, it requires us to learn only the tables up to 9, and that will do much of work. It will reduce the finger counting and also the rough work. Secondly, a lot of time gets saved by keeping our mind alert and lively. It also assures a zero-error technique. The 16 sutras that are included in Vedic mathematics are as follows. First, ekadhikena purvena, which means by one more than the previous one. Second, nikhilam navatas charamam dashataha, which means all from the 9 and the last from the 10. Third is udhaval tiryadvayham, which means vertically and crosswise. Fourth is parvatya yojay, which means transpace and adjust. Fifth one is shunyam samachya samoy, which means when the sum is the same, the sum is the 0. Sixth is shankalana kalanabhyam, which means by addition and by subtraction. Seventh is purna punyabhyam, which means by the completion or the non-completion. Eighth is chalana kalanabhyam, which means differences and similarities. Ninth is yabadguna, which means whatever the extent of its deficiency. 10th is vyashti samashtha, which means part and whole, which is also known as fractions. 11 is seshanyakena chiramena, which means the remainder by the last digit. 12th is anurupai shunyamanat, by addition and subtraction. 13 is tapante yada bharamantayam, which means the ultimate and twice the penultimate. 14th is Ekanyunena purvena, which means by one less than the previous one. Gunita, 15 is Gunita Samucha, which means the product of the sum is equal to the sum of the product, and last is Gunaka Samucha, which means factor of the sum is same as the sum of the factor. There is a lot of importance of Vedic mathematics in a student's life. First of all, we do not have to do the faster calculations and do a lot of formulas and all that. We can memorize Vedic mathematics more easily and more effectively. Secondly, Vedic mathematics will increase our problem solving speed, and this is generally also during the exams that students generally get confused. So Vedic maths helps in that as well. It improves the speed. Third is there is a least probability of making silly mistakes, and it is a very important thing in mathematics, I would say. Fourth is we can make intelligent decisions while solving complex problems in Vedic mathematics. I would like to give an example to just understand the importance of Vedic mathematics. Suppose we have a number 195, the last number is 5. So if it is given to us to find the square of that number, we have
Ankita,
to...
you are requested to finish it in 30 seconds.
Okay. So the first step what we will do is that 5 into 5 we will get 25, and the second step is 19. We have to plus 1 to it, that is 20. We have to multiply 19 into 20, that is 380. The whole answer will be 380 plus 25, that is 38025. So this is how important Vedic mathematics is in our real life. And that's all from my side. Thank you.
Thank you so much, Ankita. Now I would like to invite our next participant, Mr. Palash Das from NIT Agartala, and the topic he chose for speech is Euclid's contribution in the field of mathematics. Welcome, Palash.
Thank you. A fresh good afternoon to all of the intelligence present over here. Mathematics is the language in which the God, the Almighty, has written the universe. With this warm good afternoon to all of the enthusiastic speakers, the audiences, the intellectuals present over here. Myself, Palash Das from NIT Agartala. I am in front of you to present the topic or to speak about the topic that is Euclid's contribution in the field of mathematics. So before going to discuss his contribution, let us say something facts and about his life. So Euclid was an ancient Greek mathematician from Alexandria who is best known for his major work, Element. Although little is known about Euclid the man. He taught in a school that he founded in Alexandria, Egypt, around 300 BCE. For his major study, Elements, Euclid collected the work of many mathematicians who preceded him. Among these were Hippocrates and another mathematician, that is Exodus. Euclid's vital contribution was to gather, compile, organize, and rework the mathematical concept of his predecessors into a consistent whole, later to become the Euclidean geometry. In Euclid's method, a deduction are made from premises or axioms. The deductive method, as modified by Aristotle, was the sole procedure used for demonstrating scientific truth until the 17th century. At the time of his introduction, Elements, the most comprehensive and logically rigorous examination of the basic principle of geometry. It survived the ellipse of classical learning which occurred with the fall of the Roman Empire. Through Arabic translation, Elements was reintroduced in Europe in 1120, when the Earl of Bath translated an Arabic version into a Latin. Over the time, it became a standard textbook in many societies, including the United States and so many other parts of the world, and remained widely used until the mid-19th century, even much today. Much of the information is still forms a part of high school and Euclid's element. One must first understand the concept of axiomatic system. The mathematics is often described as being based on solely on logic, meaning that statements are accepted as facts only if they can be logically deduced from other statements known to be true. What does if it means for a statement to be known to be true? Such statement could of course be reduced from some other known statement. However, there must be some side of statement called axioms that are simple. Assume to be true without axioms, no chain of reduction could ever begin. Thus, even mathematics begin with certain unproved assumptions. Ideally, in axiomatic system, the assumptions are of such a basic and intuitive nature that their truth can be accepted. Their truth can be accepted without qualms. The axiom must be strong enough or true enough that the other basic statement can be proved from them. Definition are also part of an axiomatic system according to Euclid, as are undefined terms. Certain word whose definition must be in order for other words to be defined based on them. Thus, an axiomatic system consists of the following: number 1, the collection of undefined terms; number 2, the collection of definition; number 3, collection of axioms, and we refer basically to the postulates. And finally, a collection of theorems. The theorems are the statements that are proved by the logical conclusion of combination of axioms, definitions, and undefined terms. Now, his greatest contribution and the man who is known best for his some axioms, that is we call the Eclipse Exam. So, I am to discuss this thing also. In the elements, Euclid attempted to bring together the various geometric facts known in his day, including some that he discovered himself, in order to form an axiomatic system in which these facts could be subjected to rigorous proof. These undefined terms were point lines, straight lines, surface, and plane. To Euclid, the word line means any finite curve, and hence a straight line is a word that we could call the line segment. Euclid divided his exam into two categories, calling the first 5 postulates and the 5 is common notation in only 2 parts. The distinction between postulates and common notation is that the postulates are geometric in character, whereas common notation are considered by Euclids to be true in general. So let us discuss one by one all these 10 axioms. The first one is the first thing is the first postulate based on the
within 30 seconds.
So it is possible to draw a straight line from any point to any point. It is possible to extend a finite straight line. It is possible to create a circle with any center and any distance. All the right angles are equal to one another. If a straight line is falling on the 2 straight lines, make their interior angle can be on the same side, less than 2 right angles. The 2 straight lines, if produced definitely on their side on which the angle are less than the 2 right angles. The last one is the whole angle is greater than the part. So with this, in this short period of time, I tried to describe all his contribution. So thank you everyone.
Thank you, Palash. Thank you so much. Now I would like to invite Anna Dominic from Alfonso College, Kottayam, and the topic she chose is Euclid's contribution towards the field of mathematics. Welcome, Anna.
Hi, am I audible and clear?
Yeah, you're audible and clear.
Okay. There is no royal road to geometry. This is a famous quote by a person who doesn't need any introduction in the world of geometry and mathematics. Yes, the famous, well-known Euclid, who we often call as father of geometry. Euclid is a person who is believed to live in 300 BCE in Alexandria in the present-day Egypt. But what was his contributions, or what made him the father of geometry? It's very important to understand, especially in this 21st century. Euclid is very famous for his treatise on geometry, especially for his book, The Elements. all know that his foundations were prescribed in his book 1, which starts with 23 definitions. I repeat, his book Foundations, which are starting with the famous 23 definitions. I would like to quote here 2-3 definitions which will be familiar for everyone. The first one is, a point is that which has no parts, and a line is a length which has no breadth. Yes, this very famous logical quotes in his book made him more famous than the king in the field of geometry. The next famous contribution of Euclid to the world of geometry is his axioms. What are these? Let's look at it one by one. His axiom describes that many things which are very common and are very useful in the modern day geometric students and scholars, which are widely researched and relevant for these contemporary mathematical issues. I would like to discuss a few among you all. The first one is, given 2 points, there is one straight line that joins them. Yes, if you're given 2 points, then there is a straight line that joins these 2 points. The next one is, a circle can be drawn with a point on its center and a given radius. The next very famous axiom is, all right angles are equal in its measure. Yes. Another famous contribution made by Euclid in the field of geometry is notions. A famous 3-4 notions I would like to quote here is, number 1, things are equal to the same things are equal. The next one is, if equals are added to equals, the wholes are equals, and if equals are subtracted from equals, then the remainders are equal. The next one is, the things that coincide with one another will be always equal. And the next famous thing that made Euclid the most relevant person in the world of geometry is his theorems, especially the 2 theorems. The first one is, every positive integer greater than 1 can be written as a product of prime numbers. Example, 21 can be written as 7 into 3, and 31 can be written as 31 into 1. Same. And there are infinite numbers of prime numbers is another theorem in the arithmetic field, which was brought by Euclid. I'd also like to discuss as a concluding part of my speech that Euclid is a very well-known man who made amazing contributions in the world, in the field of geometry, which make him relevant still in modern times. Because of those contributions which were made in BC, before Christ's period, but in this 21st century, still it can solve many mathematical problems and contemporary issues. And I would like to conclude my speech by telling that the rules of this nature are there, but it are drawn by God. Yes. With this famous thought of Euclid, I would like to conclude my speech by telling that an amazing person, a well-known person who still lives in the minds of people with his works. Thank you. Have a nice day.
Thank you, Anna. Thank you so much. And here we come to the end of the speech competition. And I would like to announce Saurajita Chanda, Rahina bin Mohammed, Kanika, and Brijesh, as they're absent for the competition. They are not eligible. And now, ma'am, would you like to say a few words about this competition?
Yes, it's a great opportunity to say something in front of this interesting students, and their efforts made it a successful one. Though we have a
camera on, is it possible?
yeah, sure. So, is it visible?
Yes, ma'am.
Okay. So I found that there are 12 number of participants, out of which only 8 appeared, right? Gayatri?
Yes,
only 8 appeared. Okay. So it's a great job, and all of the participants, they did a good one. I must appreciate to all of them, and also the organizer part and the host here. You are functioning very well. I must appreciate all of you. And regarding the speech competition, yes, the content and the presentation skill are also very good. I must appreciate. So as a whole, it's very amazing and very good one in my opinion. And lastly, thank you all for giving me this opportunity to be a part of this good occasion. Now it's over to Sushmita ma'am. Thank you all.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you so much.
Good evening, Madam Dr. Devi Bhattacharya, Madam. First of all, very good evening to Dr. Devi Bhattacharya, Madam, Associate Professor and HOD, and she is now the respected judge of this today's event. And
Will it be possible to madam?
It is not possible.
So that we can take some
Sorry,
snaps.
but it
Okay,
is not
madam.
possible. No, okay. And I want good evening to all the participants present here. Here, first of all, I want to appreciate the organizer of Purvu Devnath and other members who organized such a good webinar, 5 days webinar. And also I congratulate him for successfully completion of the webinar. And today there is an event. Today there is an event, a speech competition, which is very nice, and I feel honored to be a judge of this event. Thank you to all the organizing members. I really enjoyed the speeches of all the participants. But here I need to give some marks, and so I have made some variations in marks. But every participants are very enthusiastic, and they have nicely presented. I must appreciate them. It was very good. Also, I thank to the host Gayatri. Thank you very much. That's all from my side. Thank you, everyone.
Thank you, ma'am. Thank you so much. And thank you, Baby Bhattacharya, ma'am. And thank you, Susmita, ma'am. Actually, it's our honor and it's our pleasure to have you here so that we can learn so much from you. And I would like to end this session with just a simple quote. Mathematics is not just about numbers, equations, or algorithms. It's all about understanding. And I hope you have understood at least a few from your other participants' speech. And I hope that you'll start this year by learning something every day, because life never stops you teaching. So keep on learning. So thank you everyone, and I wish everyone a very happy new year.
Happy New Year to all.
Okay, thank you, and happy new year to all of you. Thank you so much.
And the participant will get their result within few days. Participant will get their result within few days. Will get.
Okay, thank you.
Thank you, ma'am.
Thank you. Okay, bye. Bye.
Okay, bye. We are leaving. Okay, thank you.
Okay, thank you. Have a great day.